good as I'm walking around. I think for most of you, this one worked out to be, was it like 2 plus or minus the square root of 5? Was that right? Yeah. And then this guy over here, as I walked around, I think I saw it was like 6. Yeah. And then it's 3 square roots of 5 because you have to simplify the square root of 45. The mistake I was seeing for that problem was just people forgetting to simplify the radical, but the process is going swimmingly well. So I can tell that you're going to be able to handle what I'm going to throw at you today. It's a little bit weird looking, but it looks like you guys are ready for it. Does anybody, before I go on to the last part of today's lesson, does anybody have any questions about these problems? Okay, let's keep in mind we are going to follow the exact same 5 steps that we outlined yesterday in the notes. So just to scroll through, show you those. We are going to, in step 1, move the constant to the other side of the equal sign. The problem that's going to appear today is we actually have to use step 2. We didn't have to worry about it yesterday. Step 2 is we have to divide through by whatever is on or multiplied by the squared term. Well, in all of the problems in your homework last night, and the weird ones that we just did right now, the number in front of x squared wasn't even there. So it was like 1, you know. Do you see that? There was no number in front of the x squared. So we have to pay special attention to step 2. We're going to divide by any number that appears in front of our x squared term. Then we calculate our b over 2 squared, add it to both sides. In step 4, you get to factor the left and simplify the right. And then we solve using SADMEP, which is our solving by undoing. We also call that a square root method as well. So you see how the problems look a little bit different. All of a sudden, we see the presence of a number in front of our x squared. We can't factor these necessarily. We're going to actually solve these, like I said, with completing the square. So let's go ahead and do that. I'm going to make this a little bit bigger. So we have this number in front of x squared that we want to get rid of. But first things first, step 1, you want to move the constant to the right-hand side. So do you see how this is plus 3? We're going to subtract 3 from both sides. And I usually leave an obnoxious gap. We got to figure out what goes in that gap, and we do have a formula for it. But before we use that formula, we have to pay special attention to the fact that there's a number in front of the x squared. Do you see it? There's a 2 there. So what we have to go ahead and do is get rid of that 2. In order to get rid of the 2, here's how you do it. It's pretty common sense once you see it. Do you see how the 2 is multiplied by a factor of x squared? How do you undo multiplication in math class? I hear it all around the room. Good job. You divide. We need to divide this by 2 to get rid of it. We need to divide this by 2. And we need to divide this by 2. Because, Rick, what you do to one side of the equal sign, you also do to the other. So you have to divide everything in the problem by 2. It keeps the equal sign true. It keeps the sides balanced. It keeps them equal to each other. So those 2's reduce out. 2 divided by 2 is 1. So we get 1x squared, which we usually just write as x squared, plus 8x over 2. 8 over 2 reduces to 4. So that term turns into 4x. And then I have negative 3 over 2 on the right-hand side. So now it's a problem just like the other ones that we did, even on our homework last night. So now I need to figure out what number do I add on to both sides to make the left side a perfect square trinomial. So I need to go ahead and use my formula for completing the square. That formula, again, is b, which in this case, b is the number in front of x. b is 4. We have to do b divided by 2 squared. 4 divided by 2, square it up. Gets you that number that goes in that box right there. 4 divided by 2 is 2. 2 squared is 4. So now the left side is indeed a perfect square trinomial. I'm going to factor it using the square root method for consistency. Square root of x squared that's just x. Square root of 4, that's just 2. The sign that's in front of my b value is a plus, so I have to bring my plus down, and this is squared. Remember, ultimately, that your b value divided by 2, including the sign, is also what you get right here. So if you're not a fan of the factoring, you do have a workaround. So you factor the left, simplify the right. So we have to do negative 3 over 2 plus 4. You could think of that as, negative 1.5 if you want, or you could do a little bit of scratch work to add the fractions together. I'll see that quite often. So I'll see students doing like negative 3 over 2, and then 4 is like 8 over 2. Add those together, you get 5 over 2 to keep the fractions there. So that's all fine and good. You could also, 4 take away 1.5 is 2.5, and just write it as an improper fraction. That's 5 over 2. Questions so far? Almost done. I'm on step 5, the last step. Questions up to this point? All right, last step, I have to get x by itself. So I have to solve by undoing, or the square root method. So we square root the left and we square root the right. So what I have is x plus 2 equals plus or minus the square root of 5 over 2. And then I need to isolate that x. My goal is to get x by itself for these problems. So I'm going to subtract 2 from both sides. I get negative 2 plus or minus the square root of 5 over 2. The square root of 5 over 2, it's not written in the best form, but I have to teach you about rationalizing a denominator. So for the sake of this chapter, this answer is fine. You can leave it like that. But it is to be continued for sure. We're going to come back and take a look at that guy because the square root of 5 halves can be simplified a little bit. We'll talk about that in chapter 3. All right, that was a good time. Woo! Let's do it again. Part B, 2x squared minus 4x plus 1. Oh, we do quite a bit of this. What we're going to go ahead and do right now, you have 2x squared minus 4x plus 1. What we're going to go ahead and do is step 1, move the constant to the right-hand side. Now I see that there's a number in front of my x squared, and that's the big idea in today's lesson. You have to get rid of that number. How do I get rid of that 2 again? Do you know, Emma? Perfect. Thank you. And then I get x squared minus 2x equals a half. I should say negative 1/2. And now it looks like one of the problems that I did last night. So I'm going to take my b over 2 and square it up to figure out what number goes in this blank right here. So I'm going to add something onto both sides. Again, we have a formula for that. So I'm going to take negative 2, divide it by 2, and square it. Negative 2 divided by 2 is negative 1. 1 squared is 1. So that's 1. And it went right in there. And over here. Now on the left side we get something that's factorable, and on the right side we could simplify. So I'm going to go ahead and do that. Factoring the left side, typically we use our square root method. Square root of x squared, that's just x. Square root of 1, that's just 1. And the sign comes from the sign that's in front of your b value. So that guy factors to be x minus 1, or we write that as x minus 1 squared. And then negative 1/2 plus 1, that's just a half. I need to get x by itself. So I'm going to square root both sides. Remember, when you square root both sides, you need your plus or minus in there. Add 1 to both sides. And you get 1 plus or minus the square root of a half. You could simplify the square root of a half, but we won't do that really until chapter 3. So for you folks, this answer is just great. questions about that? You okay, Nicolette? Anything else? All right. Example 3. Oops, where'd it go? We'll come back to that one. Where'd it go? There it is. My smartboard's super sensitive. So these are just a little harder. 5-step process is still the same. What you're going to see in these problems is that the numbers are messier. We get a lot more fractions to deal with. But the process, like I said, 5 steps. Step 1, we're going to go ahead and add your constant to the other side. I got to get rid of the number that's in front of x squared. You can't make it a perfect square trinomial unless that 3 that's in front of the x squared is gone. So we're going to go ahead and divide everything in the problem by 3. And then right away you're probably like, oh, do you see the b value turned into a fraction? So that makes the problem just a little bit more complex. So we get x squared minus 4/3 x. And then that's equal to 5/3 on the right side. So far. We do have to do b divided by 2 and square it, because we are going to still add a number onto both sides of the equal sign. So I have to take negative 4/3 divided by 2 and square it. That looks weird, doesn't it? Fun fact, we never divide fractions. We actually multiply by something. Do you remember the phrase that helps us divide fractions? Multiply by the reciprocal. Good man. So 2, that's like 2 over 1. 2 divided by 1 is 2. So we can actually rewrite the division of negative 4/3 and 2 as multiplication. So we multiply by a half. Don't forget your squared. And then when we multiply fractions, pretty simple, we just multiply straight across. So you're going to take negative 4 times 1, that's negative 4. 3 times 2 is 6. Square it up. That's going to be the same thing as negative 2/3 squared. When you square negative 2/3, you have to square the top and square the bottom. So the value that we actually end up adding onto both sides is negative 2 squared over 3 squared, which is 4 over 9. And what I do to the left, I have to do to the right. So I plug that value into both sides of the equation. In the next step, we factor what's on the left, simplify what's on the right. So if I factor what's on the left, remember we use the square root method to kind of help us out with that because these are perfect square trinomials. We can always use this method. So you square root the first part and square root the last part. If you take the square root of x squared, that's just x. If you take the square root of 4/9, you square root the top and you square root the bottom. The square root of 4 is 2. The square root of 9 is 3. The sign in between always comes from this sign right here. So that factors to be x minus 2/3, x minus 2/3, or x minus 2/3 quantity squared. Again, if you're a person who is not a fan of the factoring, I did write this number down already. This value that goes in the parentheses with your x is always the same as what b over 2 reduces down to. So you can always keep that in mind. When in doubt, factor it out though, right? Okay, now, so that was what was on the left. I still have to simplify what's on the right. I know that to add 5/3 and 4/9, I need a common denominator. So I'm actually going to multiply the top and bottom of that fraction by 3, that first fraction there. So you get 15/9 plus 4/9. So you have x minus 2/3 squared, and then 15/9 and 4/9 is just 19/9. We then solve by undoing. Take the square root of both sides. You have x minus 2/3 equals plus or minus the square root of 19 over 9. You could add 2/3 to both sides to isolate that value of x. But the square root of 19 over 9 does simplify. You might recall that we could square root the top and square root the bottom. Square root of 19, that's a crazy number. We'll leave that alone. But the square root of 9 right there, that's just 3. So I just simplified a little bit to pretty up my final answer. So you get 2 answers out of this. You have 2/3 plus the square root of 19 over 3 and 2/3 minus the square root of 19 over 3. Questions about that? Alrighty. Part B. Last one. You ready? We're going to do it. Look at you guys already writing. Good job. So we move the constant to the right, right? So we have 3x squared minus 10x equals 2. Then, after you do 3x squared minus 10x, and that's set equal to 2, we're going to work to get rid of that number in front of x squared. So we divide everything in the problem by 3. So you get x squared minus 10/3 x equals 2/3. And then ultimately we do add a number onto both sides of that equal sign. The formula we use to find that number is b divided by, b divided by 2 squared. Remember, we never really divide a fraction by a fraction. You're going to multiply by the reciprocal. So we're actually going to take negative 10/3 and multiply by a half. So we have negative 10 over 6, right? Because you multiply straight across when you add your fractions. Negative 10 over 6. That reduces to negative 5/3. And then you square that. You square the top, you square the bottom. You get 25 over 9 added on to both sides. I usually factor then using the square root method. So I'll square root the left side. That tells me what goes in my parentheses. The square root of x squared is x. The square root of 25 over 9 is 5 over 3. And then the sign always comes from the sign in front of your b value there. That's a minus. And then I have to simplify 2/3 plus 25 over 9. I'm going to get an LCD by multiplying the top and bottom by 3. We'll finish this one tomorrow.